Okay, so we're starting more notes today. It is lesson 8-2 and 8-4. We're doing 2 and 1 because they're the same. It's called solving two-step equations. 8-4 just says solving more two-step equations. So they're the same thing. So lesson 8-2 and 8-4. Okay, so first thing we're going to look at, example 1. We are solving equations. I find this stuff fun. I like these. It says 3a plus 9 equals 33. So we have two things to solve this, hence why they're called two-step equations. But we're solving for a, so we want to get a by itself with the equal sign. So if you cover up this other side, we have a 3 and a 9 that we have to get rid of to get a by itself with that equal sign. So you always want to get rid of the one that's by itself first, kind of like PEMDAS backwards. You're going to get rid of adding and subtracting first, then we'll look at multiplying and dividing. So to get rid of that 9, since it is plus 9, we are going to subtract 9 from both sides of the equation. We always do it on both sides to keep it balanced. Then it's just one big subtraction problem. This 3a, there's nothing under it, so it comes straight down. 3a, 9 minus 9 cancels. That equals 0. We have an equal sign that comes down. And then you have 33 minus 9, which is 24. So this is your new equation. They have it really spaced out, but it is now 3a equals 24. Okay, that's an A. That looks like a 4. 3a equals 24. So now to get a by itself with the equal sign, because we are still solving for a, so my final answer is going to say just a equals, I've got to get rid of this 3. This is 3 times a, so to get rid of it, I'm going to do the opposite and divide both sides of the equation by 3. 3 divided by 3 equals 1, which is what we want. We want 1a left. Equals, that just comes down, and then 24 divided by 3 is 8. Now we have solved for a, and we're done. You can always go back and take this number and plug it into your original equation to check it. So 3a plus 9 equals 33. We said a is 8, so 3 times 8 is 24, plus 9 equals 33. So yes, we did it correctly. A is 8. Oh, I didn't mean to do that. Okay, hold on one second. I need to pull my tools back up. I don't remember how. All right, it cut off on me. But you are going to do just example 1a here. I'm not going to make you do both of them. Just do 1a. 6x plus 1 equals 25, and then I'll go over it with you. On 1a, we have 6x plus 1 equals 25. So these are two-step equations, so we are going to have two things to do to solve this. We're going to treat it as one big addition problem, subtraction problem, multiplying or dividing problem. So on this, I have 6x plus 1 equals 25. So to solve for x, I've got to get rid of this 1 and 6 because we want the x by itself with the equal sign. You get rid of the one that's being added or subtracted by itself first. So since we are adding 1, we're going to do the opposite. Well, that marker doesn't work anymore. We're going to do the opposite and subtract 1 from both sides of the equal sign. We always keep it balanced by doing it on both sides. So this is one big subtraction problem. So I have 6x with nothing under it, so that just comes straight down. 1 minus 1 is 0. I have an equal sign that comes straight down, and then 25 minus 1 is 24. This is my new equation. It says 6x equals 24. So now to get rid of 6, they're being multiplied. Sorry, that's on the video. Okay, to get rid of this 6, we're going to divide because it's being multiplied. We do it on both sides of the equal sign. 6 divided by 6 is 1x, which is what we want. The equal sign comes down, and then I have 24 divided by 6, which is 4. So x equals 4. You can always plug it back into the original to check yourself. 6 times 4 is 24, plus 1 is 25. So example 2, same stuff, but now we have a fraction. It says solve 1/5 p minus 12 equals 20. So looking at where p is located, we're going to have to get rid of this 1/5 and this 12 because here's the equal sign and we want p by itself. So I get rid of the one that's by itself first. So minus 12, we're going to do the opposite and add 12 to both sides of the equation. Okay, it's one big addition problem. Don't really like how they lined it up, but 1/5 p has nothing under it, so it comes straight down. Negative 12 plus 12 cancels. equal sign comes down. 20 plus 12 is 32. This is now our new equation. 1/5 p equals 32. So now we've got to get rid of the 1/5. So it's being multiplied. We would normally divide, but it's a fraction. We cannot divide a fraction by a fraction. Okay, we've talked about that multiple times already this past semester. So what we do instead is we flip it and multiply. So we would multiply by 5/1, which is just 5. That's all 5/1 is. So we are going to be multiplying both sides by 5. 5/1 times 1/5 equals just 1p. That's what we wanted to happen. Then on this side, we have 5 times 32, which is 160. So p equals 160. Okay, so I want you to go ahead and try one of these with a fraction. I'm just going to make you do 2a. Don't worry about 2b. Okay, so try that, and then I'll go over it with you. Okay, on this one, we have 8 equals 15 plus 1/3 n. It's just swapped around. Same type of problem. So here's my n, here's the equal sign. So if I cover up the other side, I've got to get rid of 1/3 and 15. We get rid of the one that's by itself first. It's a positive number, so I'm going to subtract it from both sides of the equal sign. Do not bring it over here. That does nothing. You do it on both sides of your equal sign. 8 minus 15, okay, so that's going to be a negative number. That is -7. 15 minus 15 cancels, and I'm left with positive 1/3 n. Okay, now we're still solving for n. We have to get rid of 1/3. It is being multiplied, which means we would divide, but it's a fraction. If you remember, we've done this quite a few times. You cannot divide a fraction by a fraction. You have to flip it and multiply. So we're going to multiply both sides of the equal sign by 3/1, which is the same thing as just 3. So it cancels over here. And I have 3 times -7, which is -21. Example 3, we have 9 minus t equals -34. So we're solving for t, so we first want to get rid of this 9. Since there's nothing out front of the 9, that means it's a positive number, so we would subtract 9 from both sides. I'm going to rewrite that out here because I wish they would line it up and down. Okay, so subtract 9 from both sides of your equal sign. One big subtraction problem. 9 minus 9 is 0. You still have negative t here. That negative doesn't just go away. Equals, and then -34 minus 9 is -43. That part you'll be able to just plug in your calculator. So now, we are not done. We have to solve for just t, not negative t. So that essentially means -1t. That's how that would read. So we would divide both sides by -1 to get rid of the negative sign. All that does is it changes the sign of everything. So instead of -43, a negative divided by a negative is positive. It is now positive 43. Okay, so let's go ahead and try 3a. Okay, I'm not going to make you do 3b because we're going to look at some more here in a second. So try 3a, and then I will go over it with you. Okay, on this one, we're solving for b. Here's my equal sign. Here's b, so I have to get rid of this. So we get rid of this -15 first by adding it to the other side. Hopefully this one didn't get you. That is a -b equals 59. Now, we can't have that. We don't want to know what -b equals. We want to solve for b. So I have to get rid of that. That means -1b. So I'm going to divide both sides by -1. All that does is change the sign. So it is -59. Example 4, last example from this section, says solve 2x plus x minus 27 equals 3. So on this one, we can't solve for x until we have just one x. So we can combine those. And since they're on the same side of the equal sign, we just do what's between them. So we have 2x plus x, that's technically 1x. So 2x plus 1x is 3x. And then you still have minus 27 equals 3. So this becomes our actual equation. 3x minus 27 equals 3. So we're solving for x. So to get it by itself with the equal sign, we've got to get rid of the 27 and the 3. We get rid of the 27 first because it is by itself. It's not attached to the x. So since it is minus 27. We're going to add 27 to both sides of the equal sign. I'm going to rewrite it up here. 3x minus 27 equals 3. That 3 looks crazy. Okay, so we are going to add 27 to both sides of the equal sign. 3x just comes straight down because there's nothing under it. Negative 27 plus 27 cancels. We have an equal sign. 3 plus 27 is 30. So 3x equals 30. This one right here is now our equation. We still haven't solved for x. We still have to get rid of the 3. Since it is being multiplied, we do the opposite and divide 3 from both sides of the equal sign. 3 divided by 3 equals 1x. Equals 30 divided by 3 is 10. X equals 10. You can always go back and plug it in, and it should be true when you plug it back in. So x equals 10 on that one. So I'm going to have y'all do 4a. So try 4a. You don't have to do this one, and then I will go over it with you. On 4a, we have 4 minus 9c plus 3c equals 58. So I have two c's. So before I can solve for it, I have to get those together. Since they are on the same side of the equal sign, we just do what's between them. This is negative 9c plus 3c. Negative 9 plus 3 is negative 6. So I have negative 6c. I can't drop that, and I still have a 4 out front equals 58. This is the actual equation. 4 minus 6c equals 58. So to solve for c, here's my equal sign. I have to get rid of the 4 and the 6. You get rid of the one that's by itself first. It's a positive number, so the opposite would be to subtract. Remember, that means there's like a little imaginary plus sign on both sides of the equal sign. 4 minus 4 is 0. I still have negative 6c equals 58 minus 4 is 54. Sorry, that was a tardy bell for when I'm here and y'all are at home still. Okay, so now, to solve for c, these are being multiplied, so we divide both sides by negative 6. I honestly can't remember what that equals. So, negative 54, positive 54 divided by negative 6. Negative 9. Duh, I had a blonde moment. C equals negative 9. So that was the last example in this section, but we're going to be doing an assignment later this week that ties a few sections together, so we're going to switch over and look at, it's the same type of stuff, just more of them. So we're going to look at a few more. Okay, now we're going to look at, we're still on the same stuff of two-step equations. This is technically lesson 8-4, but it's the same thing. It's just more of them, so we're just doing it with the other lesson. So, example 1 says solve the equation. We have 4 times, that's what that means when it's right beside that, x plus 3 equals 28. So, we've got to get x by itself with the equal sign. So, in the past, what we've done is we can't solve anything in here, so we have distributed that 4 in. Okay, 4 times x is 4x, plus 4 times 3 is 12. Ooh, my line got crazy there. Equals 28. Okay, well then from here, it's just like the other problems. We get x by itself, so I would get rid of the 12 first. Since it's being added, we subtract from both sides. That 4x comes down. 12 minus 12 is 0. The equal sign comes down. 28 minus 12, well, you could just do it individually. 8 minus 2 is 6. 2 minus 1 is 1, so 16. Then from here to solve for x, it's 4 times x, so we would do the opposite and divide to get rid of that 4 from both sides of the equal sign. That cancels, and 16 divided by 4 is just 4. Now, that is what we've learned up until this point, and that is still perfectly fine. If that way it's easier for you, do it. But now, since on this whole side of the equal sign is 4 times everything else, we can just go ahead and do the opposite of that, which would be to divide. And I can take and divide both sides of the equal sign by that 4 to get rid of it. Because we can't get rid of this 3 in here yet because 4 is being multiplied by it. So you can distribute it first and then solve like I just did here, or we can go ahead, whenever I take all of this divided by 4, it's this times this, those 4's cancel. 4 divided by 4 is 1. So I'm left with x plus 3 equals 28 divided by 4 is 7. So this is our new equation. X plus 3 equals 7. Now it's easy to solve. I just subtract 3 from both sides. When I do that, that cancels and I'm left with x equals 4. So if you notice, we got the same answers over here because they're going to get the same answer. This is 2 ways that you can solve this now. So you can either do the distributive property, or since it's only one thing being multiplied by one other thing, you can divide it to get rid of it because it was being multiplied. Okay, we're going to look at another example of this before moving on. Let me switch colors. Okay, so I have 3/5 times m minus 6 equals negative 9. So we are solving for m on this equation. So I have to get rid of these parentheses because I can't solve anything in here. So being that it's 3/5 times all of this, we can go ahead and get rid of that 3/5 by dividing. But it's a fraction, so we can't divide. We flip it and multiply both sides of the equal sign now by 5/3. When we do, that cancels this because 5 times 3 is 15, 3 times 5 is 15, 15 over 15 is 1. Well, 1 times anything is just itself. That's why it cancels. So I'm left with m minus 6 on this side equals, then we have to multiply this side. 5/3 times negative 9. Actually comes out to a nice number, negative 15. This is now our equation. M minus 6 equals negative 15. So we add 6 to both sides of that equal sign, and I'm left with m equals negative 9. Okay, so you're going to try 1a. You don't have to do 1b, just 1a. And then I will go over it with you. So 1a in our other section, we have 22 equals negative 2 times y minus 3. So if you see this and you think about distributive property, distributing that to n, since we can't solve for y, you can still do that. Okay, that will definitely still solve this. But what they've shown us is there's an even easier way. Since it's negative 2 times all of this, and we know we're solving for y, so we have to get rid of that, I can go ahead and just divide this whole side by negative 2 and this whole side by negative 2, just like we looked at that example, When I divide that, it cancels, and I'm left with y minus 3 on this side. 22 divided by negative 2 is negative 11. Now to solve for y, I just have to get rid of the 3. We add it to both sides. So then that cancels. Negative 11 plus 3, you're kind of subtracting, so 10, 9, 8, that'd be negative 8. So that's just an easier way. If it still makes more sense for you to distribute this negative 2 and get 22 equals negative 2y, those would cancel, plus 6, you could then solve for y. Subtract your 6, so 22, 2 is 20 minus 4 is 16. Negative 2y, and then divide by negative 2 here, and you still get negative 8. That is totally fine to still use that way if it's a little easier, but this is now a trick we can use since the whole thing is being multiplied by that, and we know we can divide to get rid of it. It'll cancel. We can go ahead and do that. So let's look at the next example. I believe it's example 3. Okay, guys, I know this is a longer lesson. This will be the last example we look at today. Example 3. Solve 6, and then we have times y plus 4 equals negative 15. So again, if it is easier for you to distribute to solve, that is perfectly fine. It will get you the right answer. But what I'm going to do is I'm going to do the other way only. So, well, look on this one. They did distribute. So if we take that, y plus 4 equals negative 15. Okay. I'm going to divide this whole side by 6 and divide this side by 6. I now see why they did that because it's going to be a decimal. When you divide, that cancels, and we are left with y plus 4. On the other side, let's see, negative 15 divided by 6 comes out to negative 2.5 on this side. Okay. Four. I don't know why I wrote a 5 there. That looks so sloppy. Sorry, y'all. So now we will subtract 4 from both sides. Negative 2.5 minus 4 more is negative 6.5, or negative 6 1/2, like they got here. You'll have your calculator, so you can do it this way and get decimals, or distribute, and you can still change it to decimals. That won't bother me at all. So, last problem. I want you to try 3A, and then we will go over it together. On 3A, these are just some more of the same type of problems. We have 11 equals 5 times g minus 3, and we're solving for g. Since I just have this 5 times everything else on this side of the equal sign, this whole side, it could have been on the other side, I can get rid of that 5 by just dividing since it's being multiplied. Because it's only 5 times all of that, so dividing once cancels it. 11 divided by 5 doesn't come out to a nice number. I believe it is 2.2, yep, so 2.2, or you could have just left it 11 over 5, equals g minus 3. Then to get rid of that 3, since it's being subtracted, we add it to both sides, and we get g is 5.2. Okay, we could have also, remember, if it's easier for you to distribute, that is fine. 5g minus 15, add 15 to both sides of the equal sign. And then when you divide by 5 at the end, you're still going to get 5.2. Doesn't change your answer, just how you solve it.